Hello my dear students, today we discuss something about the workability of concrete. I Dharam Singh, HOD Civil from Government Polytechnic College, Kotkapura. So, what is workability of concrete? Workability is an important property of concrete in its stage. Workability in simple terms can be defined as the ease with which the concrete can be mixed, transported, placed and compacted. The workability of concrete has also been defined as the amount of work required to place concrete and to compact it thoroughly. The workability is associated with the following four concepts. First one is ease of flow, internal friction, and second is prevention of segregation, and third is prevention of harshness, and fourth is prevention of bleeding. First is ease of flow, means internal friction. The ease with which the concrete flow depends upon the internal friction between the particles of concrete. To improve workability, therefore, it is necessary to reduce the internal friction. The internal friction can be reduced by the lubrication of the surface of aggregates. The lubrication can be improved in two ways. First is by increasing the quantity of water in the concrete mix. Greater the quantity of water, more area it can lubricate, but this method is insufficient because it increases water cement ratio and thereby decreases the strength of cement. Second way is to reduce the total surface area of the aggregates by adopting coarse aggregates, but coarse aggregate should not be used too much, otherwise segregation will take place. Next is segregation. The separation of coarse aggregate from the concrete mix in plastic stage is called segregation. Concrete is not a homogeneous material, but rather a mixture of materials of different specific gravities. So, there is always a tendency for the coarser and heavier particles to settle down and for lighter materials to rise to the surface. Segregation reduces the strength and durability of concrete. Causes of segregation. First is, now segregation takes place when there is too much of water in the mix. Second, there are badly graded aggregates. And third is, there are too much shocks to a concrete mix due to transport over longer distance, discharge of concrete from a considerable height, which is more than 1 meter, and pumping of concrete. 4 is leakage of mortar from formwork, and 5 concreting is done under waters. Prevention of segregation. We can prevent segregation as the first is, the mix should be designed correctly and minimum amount of water should be used for mixing. Second is, the height of free fall of concrete should not exceed 1 meter in any case. Third, the air entraining agents should be used for reducing segregation, as these reduce the quantity of mixing waters. Fourth one is, the concreting operations should be supervised strictly. Next is harshness. The concrete mix which does not give smooth surface with a certain amount of troweling is known as harshness. So, this mix is known as harsh mix. Causes of harshness. So, first is, the cement mortar not sufficient to fill the voids in the coarse aggregates. Second, the presence of excessive proportion of one particle size in an aggregate grading. So, these are the two causes for harshness. Prevention of harshness. Harshness can be prevented if there is sufficient proportion of mortar to fill the voids in coarse aggregates. Next is bleeding. So, what is bleeding? The appearance of water along with some particles of cement and very fine sand on the surface of freshly placed concrete after compaction is called bleeding. A good concrete should be free from bleeding. The term water gain is also sometimes used instead of bleeding. When water rises to the surface, flow channels are formed in concrete mass. Thus, concrete with large amount of bleeding are permeable. Due to bleeding, watery scum, which is water plus particles of fine sand and cement. So, this watery scum is formed on the concrete surface. This scum layer is known as lattice. This layer should be removed if a new concrete layer is to be placed over the old layer. Causes of bleeding. The first one is presence of excess waters. Second, deficiency of fine aggregates, and third is too much finishing. So, these are the three causes for bleeding. Prevention of bleeding. How we can prevent bleeding? So, bleeding can be prevented by first one, controlling the water content. Second, providing finer grading of fine aggregates. Third is using finely ground cement. Fourth, controlling compaction, and fifth is the air in training agents should be used to prevent bleeding. Factor affecting workabilities. So, there are some factors which affect the workabilities. These factors are: first one is water content, second size of aggregates, third is shape of aggregates, and fourth grading of aggregates, and 5 is porosity and absorption of aggregates, 6 admixtures, and 7 is mixing time, and 8th temperatures. So, these are the 8 factors which affect the workabilities. So, first is water content. Workability of concrete mix largely depend upon its water content. With the increase of water, the workability also increases, but too much water results into concrete of low strength and poor durability. Second is size of aggregates. Workability increases with the increase in the size of aggregate. Large size particles provide less surface area as compared to surface area given by smaller size particles. Hence, for same degree of workability, less water is required for large size aggregates. Lesser quantity of water used in large size aggregate also reduce the quantity of cement for given water cement ratio and is therefore economical. From practical point of view, the maximum size of aggregate to be used will depend upon the handling, mixing and placing equipment, thickness of section and quantity of reinforcement. Third is shape of aggregates. The particle shape also affects the workabilities. Workability increases with round and smooth surface aggregates. Crushed and angular aggregates has less workabilities because of higher and rough surface areas. Fourth is grading of aggregates. The grading of aggregate has a considerable effect on workability of concrete. Grading is more important when lean mix of high workability are required than rich mixes. For lean mixes, the grading should be continuous, whereas for rich mixes, the grading should be coarse. Porosity and absorption of aggregates. Porous and non-saturated aggregate will require more water than a non-porous and saturated aggregate. For same degree of workability, the latter will require less quantity of water. 6. Admixtures. Workability also increases with addition of admixtures such as air and training agents which produce well dispersed air bubbles. Seventh is mixing time. With the increase in mixing time up to certain limit, workability increases. Next is temperatures. The temperature at which the concrete mix is prepared also affect its workability. The slump of the concrete mix decreases as the temperature of the mix increases. So, these are the 8 factors which affect the workability of concrete. Measurement of workabilities. There are 3 tests by which we can measure workability of the concrete. So, these tests are, first one is slump test and second is compacting factor test and third is VB consistometer test. So, these are the 3 tests which we perform in our field or in our laboratory to find out workability of concrete. So, first is slump test. This slump test was derived in USA. This test can be performed in the laboratory or at the site of work. Apparatus used for this test are, so slump test apparatus consists of steel mold in the form of a frustum of a cone. The internal dimensions of a mold are: bottom diameter is 200 mm and top diameter is 100 mm and the height of the mold is 300 mm. The bottom and top ends of the mold are open. Thickness of the mold should not be less than 1.6 mm. For tamping the wet concrete, a tamping rod of steel 16 mm in diameter is used. procedure for performing this test. The following procedure is adopted for determining the slump value of concrete. The internal surface of the mold is thoroughly cleaned and the mold is placed on a smooth, horizontal, rigid and non-absorbent surface. Then the mold is held firmly in place by standing on the foot pieces before the concrete is filled in. Then concrete under test is filled in the mold in 4 layers. Each layer is tempered with the help of steel rod. The stroke should be uniformly distributed. After the top layer has been rodded, the concrete should be struck off level with a trowel. Any mortar which has leaked out between the base plate and the mold is cleaned away. Then mold is then removed by raising it slowly and carefully in vertical directions. On the removal of mold, the concrete subsides. Then slump is measured immediately by determining the vertical distance between the height of mold and that of highest point of the specimen being tested. If specimen collapses, then test may be repeated. The slump, which is the subsidence of the concrete cone after the mold is lifted up, can give the following 3 results. If the concrete subsides evenly, it is known as true slump. If one half of concrete slides down as soon as the mold is removed, then this slump is known as shear slump. If the concrete slides down as soon as the mold is removed, it is known as collapse slump. It is very difficult to measure. It occurs in very wet mixes. So, these are the some values by which we find out degree of workabilities. If the slump value is less than 25 mm, then workability is very low. If between 25 to 50, then workability is low, and between 50 and 100 medium, and 100 if the slump value is 100 to 150, then workability is high. Second is compacting factor test. This test was developed by Road Research Laboratory. It is mainly used in laboratory to determine workability of concrete. Principle of this test: the workability of concrete has also been defined as the amount of work required to place the concrete and to compact it thoroughly. It is not easy to measure the amount of work required to fully compact it, but it is simpler to apply a standard amount of work to the concrete and to measure its degree of compaction. work is applied by dropping the concrete through a standard height into a cylindrical container. The compaction in the cylindrical container is produced by the destruction of kinetic energy of the falling concrete.